So let's get started. Now, we told that we will be going ahead and writing the commands. We will tell my Kubernetes cluster what to do. Okay. And for that, I was explaining the architecture of Kubernetes. ARCHI. So this is somewhere where we started, right? We told that this is how my architecture looks like. And at any point of time, if I have to do anything, the request will come via my control plane. Okay. The request will first go to via kubectl, via third-party API, or via dashboard. Whatever the scenario is, the request will come first, hit my control plane. In control plane, you can see Kube API server, which will first take the request, see the authenticity of the request, whether it is a genuine request or not, pass it on to control manager. Control manager will go to etcd, check the current state, and from there, once it has the current and desired state, it will instruct my scheduler to do the task. Scheduler will take the task and it will go to my kubelet, and in kubelet, it will say, okay, this has to be done. This is what has not to be done. Something like that. It will go ahead and discuss or give the commands to kubelet. Once the kubelet receives this request, it goes for this container runtime environment. Okay. In container runtime environment, it can be Docker or anything else. And I have pods, which will be a layer of abstraction or a logical layer on top of my container. So whatever happens, you can see here, the cloud provider can give me the network. It can help me in load balancing, and end user can also directly communicate if he's using kubeproxy. So till this point, we have discussed that these are the ways in which I can work. Then I told that if you want to interact with your control plane, kubectl is the best guy. Most of the people, when they have to interact with AWS and all, or when they have to interact with my control plane, whether it is AWS, GCP, or any place where you have installed your machine, they will want to talk via kubectl. When it was kubectl, I told that there will be a lot of commands which we will be learning. So let me just go through these commands. So I told you, let me close this, come here. And I told you that you can start with kubectl cheat sheet. And there will be a series of commands which is available. You can take any cheat sheet which is available. Even Docker, even Kubernetes provides one cheat sheet. You can take any cheat sheet which is feasible for you. You can see there are a lot of cheat sheets available. Take any cheat sheet and start seeing those commands. In case you're not comfortable with the cheat sheets, then you can very well go ahead and start your work here. Just say interactive, INTERAC, interactive Kubernetes shell. Okay. And you can take any shell of your choice. So I'm going with the first one, which is kubernetes.io. And here I will get a stuff like this, a black and white screen where it says you can click to connect. And here it says a Kubernetes environment will be developed for you where Minikube will be running. So we came to know that Minikube is a system where the master, slave, worker node, everything will be in one machine only. So you will get this. To start this, you have to simply come here and say Minikube start, START. So it says Minikube version 1.180 will be started. This is a Ubuntu machine which comes with 2-core CPU and 2 GB RAM. Ubuntu 18.04 is running. And here you see Kubernetes 1.20 along with Docker 19.03 is getting ready for you. You can start with kubelet. You can see here there is a kubelet coming up. There is a certificate and RBAC thing coming up. Then the RBAC rules getting set up. Configuration through control plane is getting done, and all the components have been put, and storage and all has been put. And it says kubectl is now configured to use Minikube, and you can use your default namespace. So what is namespace and all, we will learn. But as of now, I know that my Kubernetes environment is up and running. I told there is a command called kubectl, and if you just want to check what version of kubectl you are running, so you can simply come here and say kubectl version. It's a minikube environment, so you can come here and say minikube version. Okay, so minikube 1.180 is running, and at the same time 1.20.4 of version of my kubectl is running. That's okay. So my Kubernetes environment is running. On top of that, I also have a Docker runtime environment, and I can say Docker -- version, and it says this Docker environment or container runtime environment is available up and running. Now I'm all set. I need to know what are the commands which I should run to make my life easy. So if you remember, in Docker, we used to run commands like docker run and all those things. Here also, we run similar commands, but with the keyword as kubectl. Now, with kubectl, how many commands are there? So you can simply come here and say kubectl -- help. When you say kubectl -- help, it gives you all the commands which are available here. Now, somebody may ask, okay, what is the function of kubectl create, kubectl expose, kubectl run, set, explain? So like this, there are a series of commands and you can start using them. Definitely, you will not be using all of them, but when you go for interview or you go for certification, there may be someone who will say, okay, tell me what is the work of describe, or he will say that, okay, from one directory, I want to copy from one container to another container, I want to copy. Can I do that? Yes, there is a command called cp. So you need to at least remember these commands. I know it will be difficult to by heart everything, but at least you should know that, okay, there is a command called cp. There is a command called drain. There is a command called diff. So like this, you should be able to at least know these commands. The best way to learn will be take a printout, keep it somewhere, and every now and then when you pass that place, you just see 2 commands, 3 commands like that, and you will be able to remember them. That's the best thing to do. Now, when I start my work, I will simply come here and say kubectl get all, means I want to see everything. So here I see that I have a service, a Kubernetes service, which is running. The default type is cluster IP. Okay. When I will be teaching services, I will be going in depth and talking about all these things. But this is the IP address and this is the cluster IP. The type is cluster IP. The service is of 3 types. One of the type is cluster IP, and it is also the default, and it is running from last 2 minutes, 53 seconds. Now, whenever I pass a command to my control plane or my master node, there are 2 ways. I told you that day, imperative, IMPERA, imperative way, which is also the ad hoc way. This way is generally used for testing purpose. So in real-time environment, hardly you will be using it, but for testing your things, whether it is working or not, quickly, you can come and use this way, the imperative way. The second way is declarative way. If the spelling is wrong, please ignore this. Declarative way. Here, you will be writing your manifest files. Manifest files are nothing but the Kubernetes files, and these are used for production grade work. Okay, so there are 2 ways in which you can pass the commands via kubectl. There are other ways also, but majorly when I talk about kubectl, there are 2 ways, declarative and imperative. Imperative is the ad hoc way, mostly used for testing and all, and declarative is the way in which you write the manifest files. So I'll step by step come and talk about all these things. So the first is imperative or the ad hoc one-time execution. Now here, you simply write the command. Whatever you write, that will be taken as the parameter, and whatever you don't write, that will be taken as default. So to start my work, I have written few commands here. So I will be using I had shared this repo link, GitHub KATS masterclass. Like this, I have generated a file. Here, if you go, there are many things which I'll be teaching one by one. But as of now, I'm interested in this guy. kubectl. And here I see the kubectl commands which I'll be using. Come to this. As of now, let me copy all these things and keep it somewhere. Okay, so this is what I started with, minikube start and then minikube version. Now assume that I have to create a deployment. Now the question will come, what is a deployment, or how do you define a deployment? So if we talk about the architecture, which we were discussing some time back, we came to know that my Kubernetes does not directly deal with the containers. So I came to know that if this is the container, on top of this container, Kubernetes will put a layer, and that layer is known as pod. But in real-time environment, do we directly deal with pod? So the answer is no. We do not directly deal with pod, but on top of that, we put a layer of replica set, and on top of that, we put another layer of deployment. So if I go by the hierarchy will be something like this. The innermost layer will always be the container, which will be doing my actual work. Then next to that will be my pod. So I told ideally it should be one pod, one container. But then if you say that I want 3 containers, I want 4 containers, you can put that. But ideally one pod, one container is the concept. Then you have a replica set followed by another component, which is your deployment. Okay, so this is the hierarchy. So when you create a deployment, automatically replica set will be created. When you create a replica set, automatically pod will be created. And when you create a pod, automatically you will see some container is running inside that. Okay, so this is what we try to achieve. So remember this hierarchy: container, pod, replica set, and deployment. Okay. Now let me go ahead and execute this diagram. Let it be here. I'm going to execute this piece of code. See here. So I'm saying kubectl, create a deployment for me with the name as test nginx, and in that use an image with the image as nginx 1.18 alpine. Okay. Now the default behavior of minikube, and because I'm running it on interactive shell, it will by default pick the image from GCR or Google Container Registry. But in case this image is not available in GCR, the second option will be hub.docker.com. 99.9% the image will be available in GCR or Google Container Registry, and it will be picked from there only. So here I can say that I have to create a deployment. The name of the deployment is test nginx, and this is the image which I'm going to use. Now, if you see carefully, I am trying to create a deployment, but I never mentioned what is the replica set. I never mentioned what is the pod. I only mentioned what is the container. So this is an ad hoc way or an imperative way of running. So here, if I simply run this guy, you will see it says deployment.apps test nginx has been created. Okay. Now, if I come here and say kubectl get all, is show me everything. So here, if you see, there is a deployment created, deployment.apps test nginx. Okay. It says 1 by 1 is ready. So 1 was requested, it is ready. 1 is up to date, 1 is available, and it is running from last 14 seconds. But I told that deployment is the outermost layer. Once you create a deployment, automatically a replica set will be created. See here, a replica set got created. And if you see here, there are some numbers generated here, auto-generated. But before this, this is nothing but my deployment. So I created a deployment and I gave the name as test nginx. So this is my deployment name, test nginx, and this is my replica set. I will say postfix, means some random numbers were added after the name of my deployment. Then this comes with the replica set. By default, took the replica set as 1. Replica set is nothing but how many number of copies of pod you want, how many duplicates of this pod you want. So I did not mention anything. So it took desired as 1, current as 1, ready as 1. Okay. And the age is 14 seconds, means from last 14 seconds, it is running. Then after replica set is done, I see something else here is called as a pod. See here, test nginx coming from the deployment, this guy coming from here, which is replica set. And finally, this guy 6b something coming from your pod. Again, it is saying 1 by 1 running, restarts 0 and age is 14 seconds. So now I can see that if I run this imperative command or ad hoc command, I have not mentioned everything. I just told kubectl create a deployment for me. The name of the deployment is this, and this is the image what I want you to use. And it created a deployment. But along with the deployment, it also created a replica set, it created pod, it created container. So do whatever you want to, but at the end of the day, this is how it will work. I want to do further customization. So I told that all these things are not possible here. What you can do is you can run it in an imperative way, means ad hoc manner. So I want to run 2 more containers here. No, those things are not possible here. So if you want, you have to go to the other method. That's why I'm saying this is mostly for your testing purpose. Okay, now I'll open it for questions. Anyone has any questions, please go ahead.
Because Rama here. Because these commands we will be, as you mentioned, like we will be using on testing purpose and development aspect, right? So apart from that, even though if it is a production, in order to use these commands, we will be using for the troubleshooting purpose also, right? Yes. So I can say that these imperative commands are also useful on regular basis for the troubleshooting purpose.
Yes, correct me. Not only for troubleshooting purpose, you can use for all the purpose. The only thing which I told is that there will be imperative commands or ad hoc execution, one-time execution. Okay. Generally, this one-time execution, see here, if I talk about this particular command, I just created a deployment like that. I just gave the container name and I created a deployment file. But in real-time scenario, you will not create it like this. Yes, if you're doing some kind of a testing, you're debugging something, whether this command is working or not, that kind of thing you're doing, then you can use this ad hoc way of operating.
Correct. If for suppose I have a manifest, so I use that manifest for the production environment. The later part somebody did something. I see that there was a issue. So in order to troubleshoot, or I need to identify the logs which is having some issue, so that I can use this imperative commands, right?
You can use these commands.
Okay.
So because regarding the deployment that you have told now, so in the real time, do we use manifest files
yes.
to create in the production, or the above command that?
Yes, I clearly told in production environment, you'll be using manifest commands. These are ad hoc commands generally used for testing purpose.
Okay. This we use in UAT kind of that.
UAT test environment kind of thing. Just you want to test it on the flight like that.
Okay.
Okay. So now
what is this service / Kubernetes?
That is a default thing. I'll teach you service. I have not taught you service till now. I will teach you service.
Okay.
Then I'll explain this more in depth. As of now, you can park it aside. So one of you have asked a question like, tell me what is a replica set. So let me say I want 3 copies of this. So this is one pod. This is one pod. I told 1 pod means 1 container. Now let me say there is a person or there is a company who wants 3 pods to run. So the replica set is 3. Now how do I make it like that? So if I come here, I will see there is a command called kubectl scale. Okay. So this is the command I'm going to use. Kubectl scale the deployment or deploy, both are same. The name of the deployment, and you say minus the replica is 3. Means here you're specifying that I want 3 copies of the container, or I want 5 copies of the container. enter. So now it says it has been scaled. Now, if you come here and say kubectl get all, you will see that this is the container which was running from last 6 minutes. The other containers just came now 6 seconds, 6 seconds, 5 seconds, 6 seconds. This is how it came up. Okay. And you can see the replica set has changed. The desired is 5, current is 5, ready is 5, and it is running from last 6 minutes, 19 seconds. So basically, replica set is nothing but how many carbon copies you want, or you can say how many containers you want to run. So I need 5, so I mentioned it 5. Now, suppose I want to not run 5, I want only 1. So I'll say the replica as 1. It says it has been scaled down. Now here, if you get, see, it is terminating 1, 2, 3, 4. So these 4 are getting terminated, only 1 is running. And here you see the desired state is 1, the current state is 1, and the ready state is 1. Others got deleted. So let me clear all these things. So if I
copy the current state of the container, right? Like current state means
I'm not using volumes anywhere as of now. So there is no copy which is going to happen.
okay. Means suppose we did any changes in the container, like any installation or
it will be terminated. There will be nothing which will be resumed or kept.
okay. No. Suppose for me, for starting, I created replica set as 1, and then I did some changes in that, like suppose some installation
See,
of
all those things you can do in your manifest file. Here, those things will not be retained. Anything which you do will be terminated. That's what I'm trying to tell you. Now, let me say I have scaled it to 5. Okay. Now, assume in this particular pod, I made some changes. kubectl. I'm just not editing it. I'm just going in describe and showing you right now. Suppose I went inside, I made some changes, okay? Now when I scale it down, whatever changes I did has gone. There's nothing left. kubectl get all. See here, it is getting terminated. So whatever you did in your container, it is gone. Okay. So that's what I'm saying. Whatever permutation combinations you want, I want to do this, I want to do that. Everything can be done in the manifest file. Here, this is majorly used for testing purpose. It will give you acquaintance with the environment which you are going to work with. It will give you a knowledge of the commands which you are going to work with. That is all what it can do. Okay.
Because my question is actually, suppose after replica, suppose we created 3 replicas, in that only we want to change one thing in the one container only, then automatically 3 containers will be replicated like in the same way?
No.
Or no?
If you change here alone, changes will be here only. You are manually changing the file. So it will not be replicated in these 2.
But at the time of starting, suppose at the time of starting only for my container, I want only for one container, one replica set. I desired count and current count is 1. Then I made changes. After that, I increased the scale up thing.
Then also no.
No.
See, that's what I'm repeatedly saying. See, you start with this container. You say, I want 5. So 5 will be created, but with the same configuration. There is no change here. You change here, it will not get replicated in all these things. You terminate this, these things, nothing will resume or nothing will be replicated.
Okay. I got it.
So yeah, so what's the purpose of having replicas if the changes in one container or like in one pod are not being reflected in others?
Yes. So you are manually going and changing it. And I'm repeatedly saying this is for testing purpose. You cannot use it for production.
Oh, okay, thanks.
Okay. Fine. So,
And in case if we keep the volumes on the pod, then the data will be saved, right?
Data. Then you will be able to retain your data. You will not be able to retain the changes done at software level. in your container, if you do a change at a software level, that stays with the container and goes with the container. You do a change at data level, that is persistent. So when we say that I'm using a volume, you are backing up your data, not the software which is there inside your thing. Yes, in case you want to make your software changes persistent, you create your own image, then push it to Docker Hub, and from there you take it. So that's the way how you do it. Okay. This is okay.
Yeah, okay.
Yeah. Fine. I'll mute you again. Fine. So if now you see here, I have a replica set as 1. I have a pod as 1. The rest are anyhow getting terminated. Now get all. So this is what I can see right now. I have a deployment file. I have a replica set. I have a pod. Now assume that I have to make some changes. Okay. My manager has asked me, so he says, show me your deployment file. So I told, okay, copy kubectl describe and this particular thing. So when I say kubectl describe and this deployment apps, whatever I have, the name is test nginx. The default namespace is default. This is the timestamp when it has been created. App is test nginx. The name has been given. The deployment, it's a deployment. And if you see, it is revision 1. Revision 1 means first version. Okay. And here the replica set and all those things are there. I told you rolling update. Rolling update is update 1 by 1. Means if I have 100 containers, 1 by 1, it will get updated. See here, at any point of time, it only 25% of the maximum capacity can be unavailable and 25% can go for update. So basically, if you have 100 servers, 25% of servers can be unavailable and another 25% can go for update. Means 50% should be always up and running. So rolling update is like when you play a bowling, 1 by 1 you roll the ball. So that's why it is known as rolling update. 1 by 1 your containers will get updated. The only problem with this is it is a lot time consuming. It takes a good amount of time to update all the containers in case you have like 100 or 50 containers. Then what I can see here is the image is nginx 1.18. Now suppose I would like to update this particular thing. I don't want this particular thing to run here. I want 1.19. So I will do something like this. I will go ahead and say, see, I'm always using a new command here, kubectl set. Earlier, if you remember, I used scale, create. So these are the commands which are changing. See here, I started with kubectl create. Now I have used kubectl scale, kubectl describe. Now I'm using kubectl set. So I'm saying kubectl set the image of deployment, which is test nginx, to nginx 1.19. Earlier, if you remember, the image was 1.18. So it says the image has been updated. Image updated. So now if I come here and say kubectl get all, you can see the old one, which was running with 1.18 has been terminated and a new one has been created in last 9 seconds. One more very important thing which you will see here is the deployment remains as it is. It says 1 by 1, up to date, available. But somebody has to keep a track what has changed. So this guy, replica set, keeps a track. Earlier, you see this guy was up and running. Desired is 1, current is 1, ready is 1. As of now, I have changed the image. So this got deleted and a new replica set has been created. And here it is saying desired is 1, needed, current is 1 and ready is 1. Now, if you go inside your deployment, kubectl describe. Now, if you see, the image is 1.19. Okay, so the image has been updated. The rest all the things are as it is. but at least the image has been updated. So you can see here 1 to 5, then 1 to 1, the image and all are getting updated. So all the steps are being mentioned here, but still you will see that this has been updated. Now my manager comes and says, okay, show me what all changes you have done. So I will come here and say, kubectl rollout history. Roll out the history, show me on test nginx what all changes you have done. So it says there are 2 revisions, revision 1, revision 2. Now I would like to know in revision 1, what all changes you have done. So I will say revision revision equal to 1. So in revision 1 or the first version, I was using Alpine 1.18. In revision 2, I was using 1.19. So these are the changes here. So revision 2, this is what has changed. Revision 1, this is what was there. So you now know that whenever you roll out an update or whenever you are updating something, what has been changed, right? Now, my manager says, it looks like this is wrong. The rollout you have done, revision 2, is wrong. You need to revert the change because this is wrong. So you should roll back or you should bring back to revision 1. So what we should do something like this. kubectl rollout undo the deployment test nginx and bring back to revision 1. So do it. So it says nginx rolled back, means the changes were reverted. So what did get reverted? Now if I come back here and say kubectl get all, I will see that it came back to the old one, this replica set. And what did this replica set represent? So this replica set represented the 1.18. If you want to confirm, you can take this guy, kubectl describe, and this guy. And you can see 1.18 came back. Why it came back? Because I did a rollback. And what was the rollback which I did? I did something like this. kubectl rollout undo the deployment and undo the deployment test nginx and go back to revision 1. If you have 5 revision, you say go back to revision 2, revision 3. You decide how much you want to roll back. You want to go 1 step back, 2 step back, 3 step back. Here it will tell you the deployment history. Rollout history will tell you how many changes were pushed. Okay. After that, you want to go to stage 1, stage 2, stage 3, whichever stage you want, you decide and you can go to that particular thing. Now assume that your work is done. You can simply go ahead and delete the deployment. So as of now, if I come here, kubectl get all. So I can see the pod is there, service you forget, deployment is there, replica set is there, but I want to delete this guy. So I'll say kubectl delete the deployment test nginx and enter, and the deployment has been deleted. So now if you come here, you will see the pod is getting terminated, and at some time you will see everything. So it's still getting terminated, and sometime you will see everything got deleted. So what I learned here is that if I use kubectl, I can run my ad hoc commands. There are many commands like kubectl create, kubectl get, kubectl describe, kubectl scale, kubectl set image, kubectl rollout history, kubectl rollout undo, and then kubectl delete. So these are the commands which I have to run in my day-to-day scenario. Again, this is mostly used for ad hoc execution, one-time execution. I just want to test. I created an image and I just want to put it in a container and see whether it will work or not, something like that. But there can be a requirement where I have to expose this to outside world. Okay, so when I run something like this, this is what I was running, right? So let me say I'm running Nginx latest version, okay? Latest. So deployment has been created. If I come here and say kubectl get all, I can see a pod got created, a deployment got created, a replica set got created. But if I go inside the deployment, or even if I go inside the pod, let me say I want to go inside the pod, copy kubectl describe and this particular thing. So the most important thing here is this is the image which is running, Docker pullable image. This is the image, and it will have something called network. Yeah, this is the IP. This is the IP. Sorry, this is the IP at which it is running. Oh, both are same. 172.18.0.3. Okay, and it is controlled by replica set. Means how many instances will be running. It is controlled by a replica set. And it is running the within Minikube cluster. So that and all is okay. But now assume that I want to see it from outside world. Means there can be a scenario, right? If you're running something on Kubernetes, you want to see from outside, like what is running inside the container. So current setup, whatever you have, it is running everything inside the container. So let me say this is my Kubernetes environment. Inside this, there is Docker container. Inside this is pod, and here it is container. Now, everything is internal. So anybody who is willing to see from outside, or this guy only is willing to go outside, that is not happening right now. For that to happen, I will be doing something called port forwarding. Now, port forwarding, how you did in Docker, almost similar to that you do here in Kubernetes also. But here you have a special component called service. So service basically does two things. First, obviously, it will do port forwarding, or it will expose your port. So you can say port forwarding or port expose, so that you can get and receive the traffic from outer world. And the second thing, it will do load balancing for you. So any traffic which is coming from outside world, it will first take it and decide on which pod it should go. Okay, so remember, service can do two things for me: port forwarding or port exposing, and load balancing. So port forwarding means making it visible to the outside world, and load balancing means anything which is coming from outside world, it will first take it, see which pod is available, and then it will distribute it to that particular pod. Okay, now when we talk about service, there are three types of service, in fact 4, but as of now we will talk only about 3. The first one is cluster IP. Cluster IP is the default one, and it is internal only, does not do anything additional. So it is internal port forwarding, it does not do anything additional, like how you see here. kubectl get all. You see a service here. This is cluster IP, and you see here it is not forwarding it to any port number, or there is no external port for this. So remember that cluster IP is internal, does not do anything for external port number. So almost this thing. The second one is node port. Node port. And the third one is load balancing. LO. I'll teach all these things in detail. Give me 1 second. Yeah, how this will go, man? Wait. And the third one is LOAD, load balancer. Balancer. Generally, when you're using cloud environment and all, you use load balancer. And in node port, the IP is fixed. The range of IP address is fixed. Anyhow, when I teach service, I will go in much detail about this. But for time being, just telling you at a very high level, service is something which will expose your application to the outside world. When you say that you're exposing, you will either be using node port or you will be using load balancer. If you're using a cloud provider, we generally go with load balancer, but load balancers can be expensive, okay, a bit costly. But if you're using for some Minikube or anything, prefer node port. Now, that is one thing. This is good with cloud, but costly. This is okay if you have an inbuilt setup. One very important difference which you must know is that come here. When you use node port, there is an IP range, or the range of IP is fixed. You can use the range only between this 30,000 to 32,767. So the range can be anything between this. But when you use a cluster, when you use a load balancer, it can be anything. So I'm telling, I will come back to this again. I'll explain this thing again to you in depth. As of now, let me go ahead and run this command. kubectl get all. This is the deployment I have. Let me delete this deployment. Copy kubectl delete and then the name of the deployment. Okay, this has been deleted. I'm going to create a new one and I'm going to run something like this. So I'm saying I'm giving more parameters this time. Okay, kubectl run sample nginx, and just one second. Why is it? Okay, so I'm not saying create this time. Okay, so I'm simply saying kubectl run a deployment or run a pod. I'll put it like this: run a pod with the name as sample nginx, and inside that pod you run nginx. I'm not mentioning anything, it will take latest. Then replica is -2 and the port is 80. So let me just run this. So it says replica has been deprecated, no effect, it will be removed in future. Okay, fine, that's okay. So what it did is it created a pod for me. So if I come here and say kubectl get all, you see here one pod got created, and inside that pod this particular nginx is running. If you want, I can go inside and see. Copy kubectl describe and this particular pod. So you can see inside this container, sample nginx is the name. And if I want to see the container, I think it is in the top. Running. See here, image nginx is running. So latest image is running here, and it is running at 80. It is 80. Host port is 0, means it is not running outside. It is only running inside. Now I want to run it, or I want to make it run outside. So I'll use something called service. Here, how to do that? So you have a command here. And the command says kubectl expose the deployment. So you don't have a deployment here. Okay, kubectl expose the deployment, sample deployment, and the port will be 80 and the type will be load balancer. That's what, there is no. Okay, first let me create a deployment. Sorry, my bad. Kubectl. Okay, wait, I did a small mistake here. Let me first clear everything. Kubectl get all. So what pod I have no here? Let me delete this pod. Okay, I will create a deployment rather than this. So kubectl delete this guy. So I'm deleting this pod, okay? This pod is getting deleted. Pod is inside the pod, container is there. So I'll create another container, or I'll create another deployment. I will use something like this: kubectl create deployment. Okay, I will say the name of the deployment, or I will take this command only from here. So I'm doing the same thing again. kubectl create a deployment for me with the name as test nginx, and there you run an image with this thing, or you run it with latest, whatever you want. Okay, create a deployment with the name as test nginx, and then we use this image. So now if I come here, kubectl get all, I can see my pod running, I can see my deployment, I can see my replica set. But we told that we will take this one step ahead and we will expose it. How to expose this? So the command will be kubectl expose. Okay, what do you want to expose? So deployment. What is the name of your deployment? So the name of my deployment is test-nginx. Okay, which port you would like to run? So I'll say -port. So 80 is internally it is running at 80. Externally you run it at any port number, and the type I will say is load balancer. Load L is capital, B is capital. So I'm trying to create a service. kubectl expose the deployment. The name of the deployment, port is 80, and type is load balancer. It says service test nginx exposed. Now, if you clear all these things, kubectl get all, you will see a service test nginx has been created. The type is load balancer. And if you see here, it is internally running at port 80, but externally it is running at port 30552. Can you see this? 30552 it is running. Let me see whether it is running or not. 30552. Display the port number, and you can see, if you see this page, nginx web server is successfully installed and working. Okay, so I can see my service up and running. Now, if I delete the service, kubectl delete whatever service you have. So service has been deleted. So 30552, should anything run? No. 30552. Still it is showing. Let me refresh this guy. kubectl get all. So the service has been deleted. Now if I go with 30552. Still it is showing, but it should not show 30552. The port number has been, or the service has been deleted. Ideally, it should not be showing. So there is some junk data which is still left, but after some time, if you refresh this and run it again, then it will should not show kubectl get all. So I can see the service has been deleted. Okay, but I don't know why it is showing here, because I have already deleted it. I don't know why it is showing here. It should not show. This is a bug in this application, because I have deleted my service. It is not available here. Okay, I can do one more thing. kubectl delete. If I delete this guy, now let me try 30552. Still it is showing. I don't know why it is showing. It may be because my browser has some cache content or anything, but ideally it should not show because it is deleted. kubectl get. So I don't have anything running. Some cache or some old content is what it is showing me. Anyhow, in the class today, I found that there are two ways in which I can talk to my cluster. The first one is imperative way, where I run the ad hoc commands, and the second is declarative way, where I write my production manifest files. As of now, we have not started with the declarative way, but we started with the imperative way. Imperative, I told, is mostly for ad hoc commands. And when I use ad hoc commands, I'll be using kubectl cheat sheet to get myself acquainted with those commands. Suppose I found a command and I don't know how to use that. I can come here and say kubectl, and let me say the command is set, okay, -- help. So it will tell you what is this set command. Okay, these commands help you. So what is the use of this command, how to use this command, all these details will be present here. So there are two important things. One, first, I need to understand the imperative way is only for testing purpose. And the second is, when I'm using imperative way, I should be very thorough with these commands. So I should know what all commands are present and how to use them. Definitely that will not come in a day or two. When you start practicing, you will 10 times make a mistake and then you will slowly learn this. But what I have done is I have created a documentation where the commonly used commands will be present for you, and you can at least start with these things. So if you go to this GitHub repo, you will see that there is something called kubectl. And here there is a common commands which we generally use. And this is a cheat sheet which is available, a PDF format. I don't say this is the best one, but this at least contains the commonly used commands which we are looking at. And then this is the PDF sheet which we are showing right now here. And here it is from your AWS only. So it contains almost everything, like how to use, what is there, how to get all these things. So it is good. Okay. So only practice can help, nothing else can help, but the commands are standard. And then these are some common used commands which very often we will be using. Okay. So we touched upon service also, but we did not talk much about service because service will come later. And then we will be going ahead and taking more on service. So now I will open it for questions. If anyone has any questions, please go ahead.
Yes, please. I'm a bit confused as of today's session because you've talked about services, we've not even touched them, and then you've talked about the replicas, we've not touched them, deployment services and all the objects. So I'm just trying to understand what's the purpose of this session, because we've not taken at least one thing properly and then we went in depth.
The way this software has been designed, okay, I cannot push everything on a single day. So if you want, I can go ahead and push, but 99.9% I can guarantee that you will not understand. But the way I've been teaching, I know this thing of sure that today, maybe you might have not understood. I don't deny that fact. But if you go through the recordings, make a note of whatever we have covered. And tomorrow when you come back, suppose you have 5 questions, you can ask at the beginning of the session. Once the questions are answered, you have an answer to them. You continue with step 2, where we start talking about the declarative way of working. There it will make a lot of sense to you. Then we add on, when we go with services, then further it will make sense to you. So what happens is this architecture which we are talking about, it is not like it is very simple and straightforward. There are many complex things which are happening in the background, and it's not possible to teach everything on day one. That's why there are many topics which I simply touch upon, and then I say, okay, fine, I'll take it next. So that's the reason I told there is service. There are 3 types of service. We will be using something called load balancer, and I just moved on from there. But I will be taking service in depth, where service, we will be talking about external service, internal service. So this is how it will go. So you will have to be a little bit patient here so that You
Okay,
get
the thing
everything.
is what you've been using, you've not even been using manifest, because manifest, this is what we basically are going to be using. You've
Yes.
just been using Minikube, so it's just all of that is from
No,
Unique.
manifest and Minikube are not two different things. See, Minikube is giving you a platform where you can run everything. If you want to use a manifest file, let me show you a manifest file. How does it look like? So if I say
No, I've already seen it. This is why I was really confused.
yes. So wait, hold on for a second. So suppose I have a manifest file. So I'm just picking a sample deployment file from the official website. Now this is a file. Okay. Now I can run it here also. So the platform is a secondary thing. The way you are running is a different thing. So if I want nano sample deployment .yaml, I'll copy paste whatever I have taken from there. Okay, so did not copy properly. There are additional spaces, but it's okay. Let me just put it properly. So I need to explain all these things, but I just want to show you that you can run the manifest file here also. I'm just removing the unnecessary spaces. Now this is my manifest file, how it will look like. I'm just saving it and coming out. And here I will say kubectl create and this sample deployment.yaml. Okay. kubectl create -f for file. And see here, deployment, Nginx deployment has been created. So if I come here and say kubectl get all, nothing changes. See here, the deployment has been created. It is 1 out of 3. So if you go inside my deployment file, and if you see this carefully, it is clearly saying the replica set is 3. So here you are exclusively mentioning the content, and here you're giving the name. So this is a deployment file, and this is how we create it. So I will explain all these things. This is the container part. This is the pod part. This is the replica part. So I will explain all these things. But if you say Minikube, you can do anything what you want. I told it's a single node cluster. You can run everything here.
Okay, thank you.
And in the replica set, for this example, there are 3 pods running, right? So if we mistakenly delete one pod, will that automatically creates?
Yes,
Because
it will automatically create that. That's concept of load balancing. So I can show you that also. If you delete one of them, the health check will start failing. So let me say I deleted this guy. kubectl delete. That was a mistake. kubectl get all. kubectl delete. So this pod was deleted. It will take some time to get deleted. Okay. Now if you come here, you can see immediately 14 seconds back, another came up. Okay. So these are running from 2 minutes, 5 seconds. This immediately came up. Let me say, and if you see here earlier, MGBT, so this was there, HL, this was also there, this was not there, DWFMR, see here in the top, DWFMR was not there. So that will be taken care by Kubernetes. If one of the container dies, it will be automatically scaled up by Kubernetes.
yeah, got it. Thanks.
Hi, Vikas.
Yeah.
Hello.
Yeah, please go ahead.
Yes. So I am creating container on Docker for MySQL, but I can't log in. How can log in my MySQL container?
Hold on, it will come. stick to what I'm teaching. There are a lot of things. Once I say that the Docker is done, Kubernetes is done, then you ask me, okay, this was left, how to go inside that. There are a lot of things.
Okay, so Docker part is still remain.
No, Docker is not there. Docker is done. In Docker, you tell me if there is something pending, I can take it.
Okay, and yes, and create how to create Linux container, and how to user access on outside
How to contain
his.
Linux container? You will hub.docker.com. Suppose you want a Ubuntu or Debian container.
Yes, on cloud. I
Take this image and run it. You will
yes,
get a Linux container.
yes.
That's it.
So I will get the I will install the container, but how can we if we go inside the container Ubuntu and create users
Hmm.
and give how to give the access to users access my container from outside,
That cannot be done. No.
like
Container is an isolated environment. How can somebody else come inside your container?
yes.
Those things cannot be done, man. While teaching
So
Docker, I told you Docker is an isolated environment.
okay, so only me access the my container.
No, see, wait a second.
Like on cloud, we have launched the instance, so we give the uh, IP or PEM file, PPK file to other user. So anybody have PPK file and IP, public IP. So DNS, sorry, DNS name. So he will access the machine, right?
He should have access first of all. There are two things here. Hold on. See, one is logging from the cloud environment and one logging within the container. So when you say that inside the Docker environment, I'm creating a container. Inside
Right.
this container, I'm creating a user. Now this
Yes.
user is different. And this user, which you're creating on a cloud environment, is different. So here you can create 10 users with 10 different access. And they can come inside, view the content, edit the content, browse the content. That kind of access can be given. But if the user is inside the container and you are saying that he will go outside, those things are not possible. Okay. So users will come with different level of permission.
Okay, so we have to give the user instance access, right?
Yes. In
So that
instance also, you can give read-only access. You can say write-only access. So those kind of access has to be granted.
okay. So on instance, we can give read only option.
Yes, those
And
options are available. Yes.
he will access the container. Okay, okay. Thank you.
Hi, Vikas.
Yeah.
So today we have talked about two services. One is node port and one is load balancer. So both are used for expose the port outside the what I mean to say from internal to external.
Correct.
So what is different between both of them?
Okay. So if you just saw this kubectl get all. See, if you see the cluster IP, so or if you see this particular service, the type is cluster IP. Okay. When you say cluster IP, I told it is mostly for internal communication only. See here, there is no external port mapped. But if you remember my load balancer example, there was an external port number mapped. And when there is an external port number mapped, let me say Nginx deployment is what we're trying to expose. So let me run this command. 1 second. The command was here. So let me say I'm running this command. The name of the deployment for me right now is Nginx deployment. Okay. Anyhow, I told I'll take service later, but let me explain this part at least. Wait a second.
No, if you want to cover later on, then no problem. We'll
No, I'll
cover
just show you. I'll show you.
it.
1 second. So first is you create a deployment. Okay.
Yes, because it is vanished.
Okay, sorry. So this interactive shell, the only one problem is within 1 hour, you can do whatever you want to. After that, it will just automatically get terminated. So this is my deployment, test Nginx. Okay, and I'm going to expose this. Okay, sorry, it should not be set image, create image.
Kubectl run or apply.
Create deployment test Nginx. Wait, let me just check.
So deploy will not work.
No, deploy will work.
Yeah,
Deploy and
this
deployment are
deploy.
same. Let me show you that.
Okay.
1 second. So deploy and deployment are same. Okay. If you
Uh,
this as deploy also, it will work.
Okay.
Okay. So you have a deployment called test Nginx. So if you come here and say kubectl get all, you will see a service which is cluster IP, but it is not forwarded to any port number. Now, if I go ahead and expose this to a particular port number, a service has been created. Now, if you see here, it is type as load balancer, and here internally it is running at 80, but externally it has been forwarded to a particular port number. So if you use load balancer, it will be forwarded to a particular port number. But if you use cluster IP, it is internal to this particular container or internal to this Kubernetes environment.
Okay. So
Fine.
port can be managed by that manifest file if you want to change or something.
Yes.
Okay.
Okay, fine. See you then, guys.